So let's say you're given a set of numbers and you're asked to double hash these numbers into a hashing table of size 7. These are the indices and they start at 0 and end at 6 for a hashing table of size 7. So how do you go about this? Well, you're also going to need two hashing functions. You're going to need h1 of x or just h of x. And let's say for this one, it's going to equal x mod 7. If you don't know what mod means, it essentially means that this whole thing is going to be equal to the remainder of x divided by 7. That's all it is. And then the secondary hashing function, let's say for this, is going to be 5 minus x mod 5. So also very similar to the first one, very simple. So what is double hashing? Double hashing is essentially incorporating these two functions, or using these two functions to find which index in the hashing table each one of these numbers is going to go into. And double hashing follows this convention, and I'm going to write it down. It looks a bit complicated at first, but once you do it, it's really easy. It says that hi of k, this being the index of k, and k being just one of these elements, is equal to h1 of k plus I times h2 of k mod m. And here, m is just going to be the size of hashing table, which is going to, in this case, just equal 7. And this is the primary hashing function, which we defined here, and the secondary hashing function, which we defined here. I is going to be an increment that starts at 0 and just goes up over time. So let's actually try and put one of these numbers into the array to see how this whole thing works. So with hashing, you just have to start with the first number and go all the way down, because in this case the order matters. So let's start with 7 and see where in the hashing table it's going to go. So let's start by calculating h0 of 7, because I starts at 0. So h1 of 7 is going to be 7 mod 7. And then since I, in this case, is 0, we don't even have to calculate the second term. We can just put 0. And then mod 7, because 7 is the size of our hashing table. And then if you take a look at this, this is just equal to 0, because 7 divided by 7 leaves no remainder. So it's going to be 0 mod 7. And once again, that's going to be equal to 0. So we just put a 7 in this space. Now, what happens when we try and put 16 in the hashing table? Let's calculate h0 of 16. Now, that's going to be the same thing. It's going to be 16 mod 7 plus 0 mod 7, which is equal to 2 mod 7, which is equal to 2. And there's nothing in the index 2, so we can put 16 here. Now, you may have noticed that this is getting a little repetitive. Mod 7 of mod 7 just simplifies to 1 mod 7. So when you're calculating when you're calculating h0 of an element, you can simplify that to equal just the first hashing function. So this would just be equal to h0 of 5. We can say directly that that's going to equal 5 mod 7 without doing this whole thing. But if that's a bit confusing for you, just use the whole equation and it'll make sense in the future. And 5 mod 7 is just going to be equal to 5. So we're going to put 5 and 5. Now, what happens when we try and put 12 in the array? Once again, we're going to calculate h0, or in the hashing table, sorry. And that's going to be equal to 12 mod 7. And that's going to equal 5. Now, what happens now? Because we have an element in 5 already. Well, that's where the second hashing function comes in. We're going to calculate now h1 of 12. We simply increment I until we find an index which isn't taken for the number to go into. So h1 of 12 is going to be equal to 12 mod 7 plus 1 times 5 minus 12 mod 5. Just mod 7. And this is going to be equal to 5 plus 5 minus 2 mod 7. So that's just going to be equal to h mod 7 which is going to be equal to 1. And there's no number in 1, so we're going to put 12 there. And now let's just continue. I'm going to erase all this, and we're just going to calculate the index of the last number, 30. H0 of 30 is going to be just simplified to 30 mod 7, and 30 mod 7 is going to equal to 2. And there's already a number in our second index, so we continue incrementing I. We calculate H1 of 30, and that's going to be 30 mod 7 plus, I'm going to move this down here, I'm going to run out of space, plus 1 times 5 minus 30 mod 5 mod 7, and this is going to be equal to 2 plus 5 minus 0 mod 7, and so this is going to be 7 mod 7, which is going to equal 0, and there's already another element in 0, so what do we do in this case? We just keep incrementing I. So now we're going to calculate H2 of 30, and that's going to be equal to, we already calculated 30 mod 7, it's 2, so we're just going to go 2 plus 2 times, this whole thing is just going to equal 5, so 2 times 5 mod 7, so this is going to be equal to 12 mod 7, and that's going to be equal to 5, and there's already a number, so what do? We increment it again, so H3 of 30, and I hope this one will work this time, it's going to be 2 plus 5 mod 7, and that's going to be 15, 16, 17 mod 7, and that's finally going to equal 3, and there's no number in the third index, so we can put 30 there. And that's all there is to double hashing. Make sure you know that you're using this equation, because some people I've seen in tutorials say that, oh, you're just going to start at h1 of k, and then if the index is full, you're just going to say, oh, it's h1 of k plus h2 of k. That's not really what it is. Don't forget to mod the m, the size. Don't forget that it is really this function, because if you don't add the mod m afterward, it can go out of bounds. That's all I have today. Thank you, and I hope I helped you with your algorithms class.